Hello there. Well, I wasn't sure whether to upload this video or not, because I have done, well, I've lost count of how many videos I've done on this project, but people seem to have some interest in them, so this one really is just tidying up a few loose ends and conclusions on the whole project. And if you make it to the end is not the end. There's another short bit afterwards about using some software that one of my viewers, Rich, sent me a link to, which proves fairly interesting. Anyway, on with the video. So, just when you thought it was all over with this low distortion oscillator project, I think this has got to be the final video, because I'm sure you're getting rather bored with it. But a lot of people have stuck with me and given me some very helpful comments. On the last video I was using the new op amp, Brown, whatever it was. Can't remember its number, don't care what its number is anyway. And of course I got no improvement on the humble TLO 74 Communal Garden cheapest chips op amp that I've previously been using. And it was a bit disappointing, but thank you so much to people who enlightened me, and I should have spotted it myself. I was looking at my audio analyzer up there with its 4 digits of resolution below 1%. And this thing of course will not stop moving around. And just because it's got 4 digits of resolution doesn't mean you're going to be able to see below 0.001%. Because as this person pointed out very helpfully, he read the manual on the 8903, which is quite an achievement, as it's several hundred pages long, and he said it's got a specification of 99 dB in logarithmic mode. If I go to logarithmic mode, I'm just getting close to 100 at times. But that's your limit. You're not going to get any better than that. It hasn't got the capability to measure lower than 0.001%. So, where does that leave me? Similarly, if you go into the calibration for this unit, which is what I've done in the past, using its internal 1 kHz low distortion signal that comes out over there, you tweak a couple of pots called notch and balance in logarithmic mode and in distortion, and you tweak it for 90 dB or better. Well, I was getting 92, I think, on its internal signal source, so that was good. And with my little box over there, I was getting around 100 dB. So that's your limit. You're not going to get any better than that. And interestingly enough, the lovely Keithley, wherever it's gone, over there, 2015, it's really hard to pin it down on its specifications for distortion. But again, if you go into the calibration routine, which I can't do, because you need a precise, very low distortion oscillator at certain bizarre frequencies. But again, you adjust whatever you do, and you're supposed to get a reading of 0.004. That is your best you're going to see on that one, which equates to 87 dB. So a fair bit worse than the Hewlett-Packard. So that is not the unit to use if you want to measure very low distortion levels. And which brings me back to where I am at the moment. I thought I'd knock up another one, because in the meantime I've been reading a lot of information on Wine, I don't know how you pronounce it, Wine bridge oscillators, this is a derivation of, and they use a stabilizing element. In this case it's a bulb. Doesn't have to be a bulb. There was a time when you could get a glass bead thermistor called an RA53, which acts the same way as a bulb. As the bulb warms up, the resistance of the filament changes, which is part of the feedback loop. So the resistance changes, the oscillator has to compensate for that, and you get a settling time until it achieves equilibrium. That's a good word. Equilibrium. And everything settles down then. And bulbs are very critical in this circuit. Somebody commented, use a 28 volt bulb. So you want something with a fairly high voltage with low filament current. Well, they're virtually unobtainable easily in this country. So I've been using 12 volt bulbs, and I knocked up another little circuit just to play around, and I found this one, which is even smaller than the one I've been using previously. It's a bit toasted. When it was in the piece of equipment it was in, it obviously got a bit hot and toasted itself, but it still works. And this is a 12 volt bulb in this little circuit, again using the humble TLO 74, so nothing special, nothing exotic. I was getting readings of 0.0010%, just over 100 dB. Occasionally it would flick over to 0.00009%, but you know, as I said, you're at the limit of what you can measure when you're getting down to these levels. So that was this one, probably one of the best ones, if you can believe that 0.0009%. Then I ordered some on eBay just to try. It's really hard to order bulbs like this because they don't normally specify the current, filament current. You want a very low filament current, and these were specified at, I think, 40 milliamps, 12 volts, and they're minute. If I take one out, I've got 100 of these, I think there's 100, I'm not going to count them now. They are minute. They're what would have been called grain of rice or grain of wheat, because they look like that, don't they, really? And these came today anyway, and they seem to work very well. I measured one at 12 volts and I think it was drawing about 25 milliamps. That's the point, you want that to be as low as possible, because your stabilising element is your main source of distortion, having read that in this document I was reading. And also, it's very critical to get the right value of a resistor there, which is responsible for the current through the bulb. And that can be a tedious process, fiddling. Originally I had 330 ohms on the previous design. Well, the new bulbs, they like 300 ohms. Well, why not? And now I've got enough of these to build 100 oscillators, should somebody want one. But I've got it wired up, of course, at the moment, and as you can see, I'm getting 0.0011 or 10. And of course, did I do that earlier? Probably not. Maybe it did. Just over 100 at times. 100 dB, which is your limit of your measurement. So what is the point is, I can't measure any better than what I'm doing. That's what's come out of all this. But I think it's quite impressive all the same to produce such a low distortion 1 kilohertz sine wave generator for probably not much money. I mean, what's the most expensive bit? Probably the op amp. Capacitors are quite expensive. 2.5% tolerance and 1% metal film resistors throughout. And I've tweaked the frequency by paralleling a resistor on one of the 16Ks. It's not quite 1 kilohertz, but it's 997 at the moment. 997. Well, that's good enough, isn't it? And the HP itself is not that precise. Excuse me. HP is not that precise because it doesn't use a synthesizer. That would be the worst way to go, is a synthesizer. For instance, that Chinese thing over there, Rigol, function generator, arbitrary waveform, whatever you want to call it. The distortion on that is fairly awful. It's about 0.02%. But then again, it's not supposed to be particularly high quality as far as distortion is concerned. And what else? Oh yes, and thanks for the person who sent me an email with a link to some software which I've downloaded and put on my computer for doing various types of measurements. I haven't really got my head around it yet. I'm not very computer friendly. Computers are not friendly to me normally, and I wonder how good it would be when you're relying on the sound card in your computer. That will introduce distortion. So I'm not sure about that at the moment, but I'm going to have a look into it, because computers are the way to go, really, I guess. I suppose we could just have a quick look on the spectrum analyzer, see what it looks like. I'm sure I've done this before. Because the good thing about this scope is it has a spectrum analyzer in it, and we're looking from 0 to 20 kilohertz with a bit of reflection. I think it's sometimes better to go into max hold. Now you can see the fundamental and all the harmonics and noise, and we're on 10 dBs per division, so 10, 20, 30, 40, 50, getting close to 60 dBs down, and that will probably be the third harmonic. If I bring up cursors, yes, that's 3 kilohertz, and it's 52 dBs down according to that, although it looks a lot better than that on the screen, but whatever. And there's one at 7 kilohertz, which is 54 dBs down, nothing else very interesting. I was seeing lower readings earlier. Most things were way below 60. I think it depends on the time of day and the weather and how my test equipment's behaving and whatever. So that's enough of that. It's looking at that, I think. And that's about it really. But let's go back to the end of the 1940s. Mr. Hewlett and Mr. Packard were doing more or less the same thing in one of their garages. They set out to build a very high quality audio oscillator, variable frequency audio oscillator, using valves. And I believe they were using the same basic design of a Wayne bridge oscillator. So they were doing that all those years ago, and here we still are with me doing the same sort of thing. But of course I'm much luckier than they are, because I've got more equipment and better choice of components. And I wonder, how did they measure in those days the distortion figures on their oscillator? I guess they must have had some way of doing it, but they were very clever people. Much cleverer than I am. Anyway, that's about the end of all this, unless anybody else has got any other ideas about what I can do. I don't think there's much else I can do. Thank you for watching this series of videos. I think I've flogged it to death now, and I don't know what else to do with myself now this is over. But something else will come along, I'm sure. Thanks for watching. Bye for now. So, I've been playing with this software that one of my viewers, Rich, sent me a link to. Free software. And one of its capabilities is basically an audio measurement type of software. Is to you can bring up a spectrum analyzer, which also does distortion measurements. And initially I put it onto a laptop, but I found that was completely hopeless. So I dragged out an old desktop, and it seems to work quite well on this machine. But it has its limitations. It's very sensitive to overload. At the moment I'm measuring up there roughly -6 dBs a volt, half a volt RMS. Any more than that and you start to see the distortion products come up enormously, disproportionate to the amount of increase. So you couldn't connect this across the output of an amplifier without an attenuator. Well, that's what you expect really. I mean, you're using the line input on the computer sound card, and it's not designed to take much more than I'm giving it now. But anyway, what we're seeing here is, I think we're going from about 20 Hertz at that end all the way up to apparently 30 kilohertz. So that's the fundamental, obviously, 1 kilohertz, and the harmonics are really hard to see in the noise. I think there's number 3 there, must be third harmonic. Okay, and but they're so low down. We're on 10 dBs a division, so 10, 20, 30, 40, 50, 60, 70, well, close to 90 dBs down there. It's a little bit at odds with what I was getting on my oscilloscope, but whatever. And if we look up here, I don't know how well this shows on the camera, but it's measuring THD at around 0.000001%, alternating and dropping slightly. I mean, I can freeze it, so I've frozen it now, and it's now measuring 0.0007, which is, I think you'll agree, a fairly low distortion level. And this is on the second board I've built with the TLO74. I'll start it up again and it refreshes. There's also a lot of stuff below 1 kilohertz. We've got things here, for instance. That is 120 hertz for some strange reason. Another one there, 150 hertz, third harmonic, or 50 hertz. And I believe that's down there at 50 hertz. Mains. But look what happens if I disconnect the earth. I've got a mains earth connected to my board using the crocodile clip from my scope probe. Wow, it doesn't like that, does it? Look at that 50 hertz signal now. That's massive. So obviously you need a reference, a mains earth on your piece of equipment. I'll put it back on again and you can see how it disappears. So, you know, for a free piece of software I think it's fairly impressive, and I probably will use it in the future. It's just I haven't got any room for a computer in the workshop. I wish I had a place to put the computer, or a smaller computer. I don't like computers in the workshop, unlike most people these days. Anyway, if I want to I can save that. I can take a screenshot of that, but that's really what I wanted to look at. And I think this really is now the end of the project, but I've learned so much from this project and I hope you've got something out of it as well. Anyway, thanks for watching. Bye for now.